Here we have our question for Chapter 9 on molecular geometry. And this question states, first draw the Lewis structure for xenon difluoride. Then determine its electron domain geometry, molecular geometry, and formal charge. So this question is asking for three things, and the first thing that we'll do is draw the Lewis structure. So if you look on the periodic table, we know that xenon will have 8 valence electrons, and fluoride has 7, but it's difluoride, so there's 2. So the total valence electrons is 22. So when drawing it out, we'll have xenon in the middle, put fluoride on each side for right now, and then we'll just put the valence electrons around it. So you have 2, 4, 6, 8, 10, 12, 14, and 16. And so we still have to go up to 22. So we'll have 18, 20, and 22. And that's the one that we're going to be using for now. So to find its electron domain geometry, we're going to be looking at its electron domains. So if you count, you have 1, 2, 3, 4, 5. So we have 5 electron domains. And that gives us that it's a trigonal bipyramidal. Oops, I spelled that wrong. Okay. Then to find its molecular geometry, which I'll write down here, just so we know, we want the number of non-bonding pairs. So here we have 2 that are bonded, and then these 3, so you count 1, 2, 3, are not. So that makes it linear. If you were to take these 3 off, it would be exactly linear because you have the 1 bond here and 1 bond there. So here we have found its electron domain geometry and its molecular geometry, and the last thing we need to do is find its formal charge. So we can start by looking at xenon, and here we know that it has 8 valence electrons. And on our Lewis structure, we're going to count how many valence electrons it has. So it has 2, 4, 6, 7, and 8. So you subtract it, and it has 0. And the reason why these count as 2 and this is 1 is because these are non-bonding pairs, and this is bonding, so this only counts as 1, whereas these count as 2 individual. Okay, next one we'll do is one of the fluorides. So we'll do this one first, and it normally has, as up here, 7 valence electrons. In the Lewis structure, it has 2, 4, 6, 7. So that's 7, and that gives another 0 formal charge. And we'll do the other fluoride. It again also has 7 valence electrons normally, or it should. And then we'll count, we have 2, 4, 6, and 7 again. That also gives it 0. So xenon difluoride has a formal charge of 0.